Hello, statistics students. If we take a look at this problem that is on page 181, 182 of your textbook, the goal is to use the formulas here that the slope is r times the standard deviation y over standard deviation of x, and the value of a, which is the y-intercept, is given by that I highlighted in green, to find the least squares regression line that I highlighted in blue. The secondary goal then would be to interpret the slope and the y-intercept like we were doing in class. So this particular problem, we do need a little bit of context. So bridges are ranked on a scale of 1 to 7. That's their score. If they are score less than 5, then that means that they are deficient. So that's something that we need to take into account. So let's find the least squares regression line, and then we'll do the second part. So the value of the slope, b, is r times the standard deviation y over standard deviation of x. So on my calculator, I'm going to type negative 0.634 times 0.887 and divide by 28.70. And when you do that on your calculator, I'm going to show you my calculator. I typed that in. I came up with negative 0.0196 roughly. So I'm going to write that down. That b is approximately negative 0.0196. Then we will need to find the y-intercept. So y is equal to, or the y-intercept a, 5.24 minus the value of b, so negative 0.0196, I'm going to show you how to do that on your calculator, times x bar, which is 47.86. So when we used our calculator and typed that in, remember how Cole did it, or we use the answer button, whichever you prefer. So we're going to do 5.24 minus, some of you like the answer button, so I'm going to press second answer, and then times the 47.86, and that'll get me the y-intercept. Others of you liked the way Cole showed us, so 5.24, Cole is one of the students in period 9, minus, and then Cole liked to press the up arrow key and highlight the value, and it'll type that number in, and then you can say times the 47.86. Either way, you will notice you get 6.177. So the value of a is approximately 6.177, and I want to get 4 decimals, 778. So then to write the least squares regression line, so the final step would be y hat is equal to 6.1778 minus 0.0196x. So that's using the formulas to find the least squares regression line. The second part of the problem is to interpret slope, and does the y-intercept have a meaningful interpretation. So this problem came from the book, and if you look at page 182, you will see a scatter plot, and on the scatter plot, the explanatory variable is the age in years, and the response variable is the score, which is from 1 to 7, and remember, a score of 5 or less means deficient. So let's look at the slope. So the slope is negative 0.0196. I'm going to put that over the 1. And then I'm going to write the variables that go with that. So the y is the score, and the x is the age in years. So the way I would interpret this would be the following. On average, for every additional year, the score on about the bridges decreases, since it is a negative, by about, and here I'm going to round to 0.02. So on average, for every additional year, the score about the bridges decreases by about 0.02. And then the second part of this problem is, does the y-intercept have a meaningful interpretation? So if x is 0, y hat would be 6.1778 minus 0.0196 times 0, which is 6.1778. So does this have a meaningful interpretation? So I would think that this does have a meaningful interpretation. If bridges were built, I would anticipate the score to be high. It may not be a perfect 7, but at least if the score is around 6.2, that seems reasonable. So I would probably say yes. New bridges have a score of about 6.2, and I'm going to kind of put this word on average again, since it is using the least squares regression line. So some new bridges probably score a little higher, some new bridges probably score a little less, and then over time they need to continue to maintenance them and keep that score above 5 so it's a useful and safe bridge.